Hi, Al Williams here. I wanted to give you a quick demo of the PlatformIO IDE, and it's actually the Atom editor or IDE with a plugin, but they've done a nice job of integrating this one, more so than the Visual Studio Code where the integration was pretty light. This is fairly tightly coupled. You can see there's a nice screen here with some choices. We can make a new project or import an Arduino project, or we can open something that exists, or we can go look at example projects. But if you notice, the sheer number of boards this thing supports is just insane. This looks like 10 pages, but actually it's even more than 10 pages. So just page after page of different parts from different vendors, different boards. In particular, though, I've got an STM32 blue pill. You can see on the platforms too. Just everything from STM32, which is what I have, Teensy, TI, Microchip, NXP, Freescale, ESP 8266 and 32, obviously the Atmel for Arduino, and that's just on the embedded tab. If you look on the desktop, I mean, even if you're developing for the Linux desktop or for Windows, if you look at the frameworks, it supports lots of different frameworks. So lots of things that you can do here for lots of different platforms. I'm going to go ahead and create a new project, and you can see going through this board list is really tough. There's just lots of things. So I'm looking for the STM32 again. And I've got the blue pill. There it is. And then for the directory, I'm going to pick this demo directory just because it's not going to stick around forever. And this really just runs a command line tool that you could have run yourself, but it initializes this directory and opens it up. And what you'll see is in that directory, there's a lib directory, a source directory, there's some Git framework, and in particular, let me make this a little bigger, there's a PlatformIO.INI. That's kind of your project file, and it's pretty straightforward. It's just text. You'll notice that it assumes I want to use embed for the blue pill, but right now the embed build seems to be broken. And so I'm going to go ahead and just change that to Arduino. And that was one of the things I mentioned in the post, is as far as I can tell, this was the only way to do that. So it's, oh, well, this is all very graphical toolkit until you have to come in and put entries in this file. I don't mind that, but it just seems like a bit of a design dichotomy, if you will, of saying, well, all this stuff's on the GUI, but then you can go edit this file. And there's a lot of keys that you can add here. If you need to set, say, a custom upload port, things like that. So that means you got to know what the key name is, and it is well documented, and you got to know what the choices are that you can put there, which, because of the plugin architecture, isn't always as clear as it could be. So I will go ahead and save that. And you get a lot of little messages about different things. All your source code has to go in the source directory, and right now that's empty. So I'm going to go ahead and make a new file. I'll call it demo.cpp. Now I could have called it .ino, and then it would treat it just like an Arduino file. But instead I've made it a CPP file. It seems to like that a little better. And it's essentially everything that would normally be in a Arduino file, except I had to go in and manually put in the include Arduino.h. So this is a slightly modified one of the stock Arduino demos. This is actually from an earlier post where I did the debugging, and so I'd added a few functions and a few little pieces of algorithm here just to make it a little more interesting to debug. That's not really important here. And of course I could have multiple files and do all the kinds of things that a normal IDE can do that you might not be used to from the Arduino IDE. So you can do all kinds of interesting tricks with selections and finding and code snippets and, you know, all these different things that you kind of expect out of a modern editor. So let's go ahead and try to do a build and see how that works. Now, I happen to have all the different pieces required to do the build, and you'll see it knows it didn't that I changed this and didn't save it, so it's making me save it. But normally it will come up the first time and say, oh wait, I have to install this Arduino package for you, I have to install this STM32 package for you, and it pretty much does that all in the background. And then after you do it once, you don't really have to do it again unless something upgrades, and you can go in and actually upgrade them. So the build was successful. Obviously, if it hadn't been, you'd have gotten error messages, and you could jump up into the code in the right spot and things like that. That's kind of convenient. In fact, let's just introduce a deliberate error in there for just that reason. If I said build here, save, you can see it came up and gave me an error. And it gives me a lot of details about the particular error. So that's one I particularly introduced. Digital write. I think that's right. So now I'll do the build again. And now we're back to success. So it's kind of convenient. And then same way with the upload. In this particular case, it should find... Oh, see, it didn't. It didn't find my ST-Link hardware. Well, actually, I think that's that I didn't get it reset well. So let's try again. That may be my fault. But again, that's one of the problems I've had with this, is that given that it's probably mostly of use for folks that aren't aware of what to do to build this stuff, when you get some error message like that, it wasn't real clear why that happened. And granted, because I do all this without using these kind of tools, it was easy to go, oh wait, I see that's happened before. But it's really tough, and a lot of times it'll give you some error that it's kind of hard to interpret why the error actually occurred. That was especially true with trying to build like the embed libraries, where apparently something had changed. I was getting an error message, and I really had to go dig into their tool chain that they install to go figure out what part of the build mechanism was breaking the build. And so it's running. So that's pretty good. And again, you can do things like import an Arduino file, a whole project into here. I could easily retarget this to go to one of the KLM boards that I've got sitting here, or a Raspberry Pi, or the Linux desktop. Obviously, some of these calls wouldn't directly translate, so that's where you get into trying to find libraries or writing your own interface libraries that would insulate those differences from you. So that's another topic. But the point is this one IDE that you could learn and understand how to make work has enough mechanism in it that it will install a tool chain, install a programmer, and work with all those different platforms that we just looked at. So that's pretty impressive when it works. And like I say, when it breaks, it's a little painful, but it's impressive when it works. Anyway, just a quick demo to whet your appetite. I did talk a little bit in the post about Microsoft Visual Studio Code. Honestly, the integration is not very tight like this. It's very similar, but like to create the project, you have to go in on the command line and type stuff, which, I mean, isn't so bad, but it's just not very well integrated. Code Studio or Visual Studio Code looks sort of like this, got the same sort of color scheme, same kind of arrangement with the folders and the buttons. So really, it's not visually very different, other than you don't have the nice GUI tools for doing creation. But it's the same kind of thing. You can do a build, you can do an upload, and everything's really controlled through this PlatformIO IDE file. Anyway, hope that gives you something to think about, and thanks for watching.